Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, coaching the team here with Dave Vellante, my co-host.
Welcome back to theCUBE studio here at the New York Stock Exchange. This is AI Factories, one of our programs with NYSE Wired. And on AI Factories, we talk a lot about maximizing GPUs in data centers. But joining me now are two gentlemen who want to talk about bringing AI to the edge. Sammy Cheung, CEO of Efinix, joined by Bob Beachler, Head of Marketing and Corporate Development. Welcome, folks.
Thanks for having us.
Delighted.
Thank you.
Delighted to have you. So, folks, you were here at the NYSE in January, a little over 5-6 months ago. Feels like a long time, though, in the world of AI factories and this space. Talk us through some developments at Efinix since you've last been on the show.
Yeah, sure. So I'll turn it over to Sammy to talk a little bit about the business. As you said, 5-6 months, a lot can change. We entered the year feeling pretty positive, but so far it's really exceeded our expectations. So Sammy?
Yeah, since January was first time after we closed 2025, and we got an exceptional year in 25. We grew over 115%, and thought, okay, was it like a one-time phenomenon for big growth because some market demand? But it turns out that momentum is actually continuous. And as we have validated that, I mean, most of our design wins and also the growth is supported and propelled by the demand in the edge AI space. So this year we are looking at another record year. So we are very convinced that, of course, not only AI is real, everyone understands that like I say what you said, the data center AI is fantastic. I mean, it set up the foundations for a lot of compute capacity. But now we personally get involved in driving the growth on the edge AI side and witnessing in real time the explosive growth in the business.
I mean, I think it's been an interesting year for the world of the edge, right? And what it means, what physical AI on the edge means. It was a topic that really wasn't a headline front and center topic just even 18 months ago. But it's certainly having a moment because I think we're increasingly seeing the importance of having intelligence on physical devices, in all sorts of proximities. What is it exactly that you folks and the team at Efinix are hoping to achieve? Like, where are you really doubling down on opportunity?
Yeah. And so for us, the difference between the data center and the edge is that, first of all, the data is much different. In the data center with generative AI, it's primarily text-based, whether you're coding, whether you're using large language models. But at the edge, we're in the physical world. So the data that's coming in is multimodal. There's imaging, there's thermal, there's pressure sensors, LiDAR, radar, ultrasound, you name it. We're trying to understand what's going on in our physical world and then being able to process that in real time in a deterministic manner, so that whether you're working on a factory floor, a vision-guided robotics, autonomous vehicles, the problem is actually much more difficult when you talk about AI on the edge. And that's why it needs a hardware solution, and in particular, a programmable hardware solution like FPGAs that Efinix makes, because without that, you just don't have the compute power, you don't have the speed and the latency necessary to deal with what's happening in the real world. And so that's what we're seeing, right? And that's why we're seeing such great growth, is that all of these companies, whether you're talking about humanoid robotics, or you're talking about machine vision applications, medical equipment, they're all using AI, they're all changing their sensors, the data sets that they need to train for, and therefore the problems that they're trying to solve in the inference. And that's why we're seeing, such a really great opportunity.
When we think about the world of data centers, right, it seems as though the narrative is do more, 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 more with more, more with more. When we think about the edge, it's really almost like a counter narrative. It's like do more with less, right? Lower power, lower I guess, demands or requirements from the perspective of what you can achieve with less. Bring that to life for us. Give us some examples of some customer use cases or some prototypes that you folks are both working on that really, I guess, exemplify how the edge differs to the kind of, the other race that's happening in industry right now.
Yeah, certainly. So the space constraints and the power constraints that you mentioned are critical, right? So if you think about even an application like a humanoid robotics in the hand, we're seeing people looking at solving the robot hand problem by putting multiple sensors in every finger. And then inside of the finger of the robot, you have the processing. So putting in an FPGA that's only, 4 millimeters by 4 millimeters in size, but it's doing the sensor aggregation, processing, fusion, and quick, low latency response. And then it's also communicating back to the main processing unit in the head of the robot. Those are the types of things that, are very different than a data center.
And this world, moving increasingly away from what was like a fixed function world to a world where devices and sensors and, different types of machinery, cameras, robots, vehicles, whatever it might be, are actually almost updating instantaneously is obviously a huge technical shift, right? It involves a whole different level of architecture. What does that look like? Like how, break that down for the audience.
Yeah, Sammy, you want to take that one?
Sure. I think you're right on. I think this is what we talk about at the edge. It is the real world, right? In data center, it's a machine world, it's a virtual world, but in the real world, everything is different. And they happen at different time, very fragmented. But what's interface with real world is what Bob mentioned just now. Is about all sort of sensors. And all these sensors and what we need in today is not just a sensor passing back to data centers coming back. Everything need real time and low latency. So in order to do that, the FPGA is the best. But what makes Efinix stand out in this area is truly the efficiency of our innovations and the real-time programmability adding on top of be able to deliver highest performance, lowest power, and smaller size is where we see we are shining in any space near the sensor or data aggregation or after aggregation, helping the processing. And on top of it, you can view sort of what the world really need is like another platform. GPU is clearly a standard platform for data center. However, in terms of looking at be able to handle very fragmented different applications in real time near the edge, FPGA is the best, and FPGA provide that efficiency and turnout is standing out in the industry, in the marketplace.
We had an event here at the NYSE last night with the neocloud player TensorWave, and we talked about the competing world of, neoclouds right now. They're all in an AMD. We talked about CUDA and that moat, right? And the fact that the software layer, of the data center divide has been pretty effective in basically building a defensible moat. When it comes to the edge, what does that software strategy, that software layer look like? And what are, the competitive forces at play there?
Yeah, so in our case, because our devices, when we ship them, are blank, right? The user designs the hardware that gets programmed into the FPGA. So unlike a processor or a GPU where you have sequential C code or Python, we're working in what's called a hardware description language. So the tool flow that we provide to allow our customers to get their hardware design into our FPGA, along with their C code, because we have embedded RISC-V processors, along with getting their AI model into our FPGA, because we have an entire AI design flow to lower the model and accelerate it on our FPGAs. That's a tremendous amount of software. And that development kit, in our case, we call it the Efinity SDK, is a big amount of our engineering resources. And we provide that free of charge to our customers, but it is certainly a moat in that regards that once they become familiar with it and use it, they don't want to change. And so we spend a lot of time engineering that and making it as easy to use as possible.
Well, that's a great position to be in, Bob. In terms of these customers, these use cases, can you talk us through some examples? Bring this to life for us. You mentioned humanoid robots with sensors in every finger. Fascinating stuff. How is this being actually used effectively in the field? And I guess, what's this maturity curve look like as well? I'm interested to understand, is a lot of this stuff still prototype, or is it actually live active devices we may not know are running on Efinix?
Sure, it absolutely is live active devices. So what AI has done in the edge is that it's made existing applications better. So think of everything from like a portable ultrasound system that now has AI, or an endoscopy system that can now recognize tumors in real time, as opposed to going back to a radiologist. Think about your autonomous vehicles processing LiDAR, radar information, machine inspection in terms of finding defects on the factory floor. It's really broad and it's all over the place. So it's making those existing applications better. They're faster, they have more features, but it's also enabling these new applications that you couldn't have had without AI, like humanoid robotics. I mean, 10 years ago, it was an intractable problem. Now people are really in the nuts and bolts solving these issues in terms of robot hands, in terms of guidance, in terms of what's called transferability. Can my robot go from a bedroom to a laundry room to outside walking the dog without totally losing its mind, because each of those is a different data set and a different set of tasks that it needs to do. So it's a mix of both. It's the new applications also making existing stuff better.
We hear a lot in the generic AI factories conversation around bottlenecks, right? And there's of late somewhat of a divide as to what the key bottleneck is. Is it energy? Is it power? Again, it's kind of a moving problem, if you like. In this world, in the space you guys are in, what are the true bottlenecks right now? Like, what is the one thing that if you could solve tomorrow, you would?
Sammy, you want to take that?
Sure. It's going back when you mentioned energy. The tolerance in the edge is very small. I mean, basically, it's all limited by the sort of the thermal and size. Imagine we deal with a lot of sensors. Sensors is very sensitive to heat. So in this case, that in the past, I mean, when there's no real-time requirement or no compute requirement near sensor, that's perfectly fine. You can put a very passive processing device next to the sensor. But nowadays, when we start talking about real AI at the edge, and everything else is real time, need to process into it, and then it has to change as well. So the thermal, which mostly is driven by the power consumption itself, it's very, very critical. So as I mentioned previously, the requirement, it has to be all three factors, right? It has to be in a real time processing, has to be lowest power that enable the thermal, has to be high performance, and then small. Everything has to come together. And turns out we have that solution, and we have the technology that can enable it. And also we are looking at a roadmap that can even make it better and better. And that is exactly why we see explosive growth in the marketplace. And just a reminder, FPGA is not like a single custom chip. The same silicon and same chip can be used for so many things like LiDAR in the autonomous machines, and all sort of industrial cameras. And exciting part, what Bob mentions, is the physical AI, robotics, humanoid deployments, and they have the same equations, thermal and energy, and it is super critical. It cannot be. It's not like you build up more electricity can solve it. It just cannot deliver if you cannot deliver lowest power, highest performance today. And very grateful that we have that technology, we have that innovation can support all the physical AI innovations.
Yeah.
And
So the data center, you're talking to the TensorWave folks, they think in kilowatts and gigawatts. We think in milliwatts, right? We're orders of magnitude divorced from the data center in terms of the constraints and our biggest problems that we're solving for our customers, which is that energy efficiency and power consumption.
And it also seems like a space that had some long tail opportunities that have become very real very fast, right? Where are the kind of highest demands that you guys are seeing? Where are those customer demands coming from? What sorts of industries and verticals, I guess, are quickest to the edge, to land and expand on the edge?
Boy, it's really hard to nail down just one. We've mentioned some during this interview. Certainly anything autonomous, whether it's a robot on a factory floor in terms of, vision guided robotics, whether it's an autonomous vehicle on the road, a humanoid robot, anything that needs to be able to have self-actualization and be able to interpret the world and be able to use that. That's certainly a super fast growing market. But also, as I mentioned, some of which you consider, older, more industrial applications like factory floors and machine vision, things like medical equipment. AI is just pervasive at this point. And so it's changing the way people are designing these systems. And whenever there's change, they need a programmable solution like what we offer.
Well, folks, what's ahead? I mean, a lot has happened since you were here in January. It sounds as though you guys have certainly, really found an incredibly competitive market and you're leaning in. I know you're a market leader in the space. What does the next 12 months look like? How do you stay, heavy as the crown and all that? How do you stay ahead?
Well, I'll talk a little bit about the product and let Sammy talk about the business. So on the product side, we're going to be announcing some new products here in just about another week or so that are really focused, again, to continue to improve our solution for edge AI applications. So, we're continuing to focus on that in terms of making better products and delivering them in the shortest amount of time that we can to our customers, because there is this kind of insatiable demand. But Sammy, perhaps you can comment on the business side.
I think on the business side, the two ways. The market is actually really putting us into that because of our technologies, and the adoption rate is huge. I got to mention just now is specific market. You talk about industrial, automotive, communications are all growing crazy now, adding on the physical AI on the robotics side. So that is good. But on the other hand, we're also pushing our growth as well. I think we are investing in all fronts, scaling up pretty fast. It's not just adding people, but we have Bob mentioned we have a new product announcement. We also have a very interesting roadmap, continue our commitment to support the physical AI area on the silicon side, on the system integration side, and also on the two-flow integrations. And then on the marketplace, one biggest things that we are investing in helping our growth is the ecosystem. Imagine we are not just trying to sell a silicon, a chip. We actually is a platform, is an enabler for a lot of innovator. And the edge AI, or even, totally related data center as well. Data center needs a lot more quality data. Where it comes from, it comes from physical AI. It comes from edge AI. So we are the enabler, and we want to scale ourselves to embrace the ecosystem. On and off, I would expect the market will see us working closely with different partners, whether it's bigger companies, smaller company, hardware, software, IP on the AI company. And that's where we are. And we are committed to be that centerpiece and helping the innovations to come to the market as quick as possible.
Well, I love that one word you mentioned, Sammy, ecosystem, right? Because if tech is about anything, it's about the power of ecosystem. And a rising tide lifts all ships, as they say. So Sammy and Bob, thank you so much for joining us on theCUBE.
Hey, Gemma, thanks for having us. It's been
Gemma,
wonderful. We look forward to working with you in the future.
We hope
thank
so.
you very much.
I'm Gemma Allen here at theCUBE's NYSE studio. This is AI Factories, one of our programs for NYSE Wired. Thanks for watching.
Clear.